So it looks like this is going to be our classroom for the next few weeks. So what I'm going to do is every week I'm going to upload a video of me teaching you what you need to know, and then you will get a choice board, and you will need to pick 3 things off of that choice board to do that make a tic-tac-toe. So they have to be 3 in a row, okay? So if you pick the one in the middle, it has to make a tic-tac-toe using that one in the middle, okay? And I will be available to help you do these through a Google Meet. You can call me, you can text me, you can email me, okay? And we will get through this, okay? So before we left, we were studying the phases of matter, solids, liquids, and gases. And we were starting to talk about how if you add energy to a liquid, usually in the form of heat, those molecules are going to speed up and it's going to become a gas, right? So what we're going to do is we are going to learn how that happens. You're going to review potential and kinetic energy, and then we'll talk about the forms of energy, and then you'll actually learn about what happens to those molecules. So you're still going to have an I can statement. So your I can statement is I can use a model to describe the process of energy transfer. And I just realized that that is completely and totally backwards. So what I'm going to do is we're going to make an anchor chart. We'll make your anchor chart, and then I'm going to post a picture of it on Google Classroom. Your first day assignment every week is going to be to copy that anchor chart, take a picture of it, and upload it to Google Classroom to show me that you did it, okay? Now, these videos will never be more than 30 minutes long, a 30-minute class. All of your assignments will probably take about 30 minutes, okay? So, that's what you're going to have to do for science. If you need me at any time, do not hesitate to ask, and I will help you through this, okay? So we are going to do a quick review. Everybody has already learned this whenever we learn Newton's laws. We're going to go back over the 2 types of energy, kinetic and potential energy. So, what is energy? Is the ability to do work. Like I said, this is going to be backwards. I will take a picture of it and post it for you, okay? So, we know that in order for anything to happen in science, there has to be energy, right? In order for our body systems to work, we have to have energy in the form of calories. In order for Newton's laws to work, we have to have energy to put an object in motion. In order for chemical reactions to occur, there has to be energy that makes those chemical reactions occur, which is what we're studying right now. So, energy is organized into 2 categories, potential and kinetic. So we have potential. I wish I would have bought some fatter markers, but it's okay. And kinetic. So potential energy is Potential energy is stored energy that can do work. And I always tell you all to remember potential energy as it has the potential to move. So whenever I have an apple and I take it back like this, if I were to release my arm, the apple would go moving, right? So right here, it has the potential to move. Now, I'm not really going to throw this because it is glass. If there is a soccer ball laying on the ground and I bring my leg back to kick it, it's potential, right? It's not moving, it has the potential to move. So, kinetic energy is energy that does work. Now, I always tell you all to remember kinetic energy is energy in motion. So it is moving. Now, we're going to use a roller coaster as an example. So whenever the cart is right here, does it have potential energy or kinetic energy? Here's a cart right here. Does it have potential or kinetic? This one has potential energy because it's sitting up here waiting to move, right? So it has potential energy. Now, you will notice this hill is higher than this hill of the roller coaster, right? So this one right here is going to have the highest potential energy. And then on top of this hill, where it has that lag before it goes down, it's also going to have potential energy. It has the potential to move even though it is not. So right here, we're going to have potential energy again. However, the potential energy up here is higher than it is here because the hill is higher. So it has got more time to release that energy. Now, right here, as it's going down the hill, it has kinetic energy, okay? And because the hill was so high, it has a lot of kinetic energy. It has the highest amount of potential energy. That energy transfers to kinetic as it goes back up the hill. Potential energy goes down the hill back into kinetic energy. Now, does it have more kinetic energy here or here? The answer is going to be here on number 1 because the potential energy was highest right before that. And we know that energy cannot be created or destroyed. So energy cannot be created or destroyed. So however much kinetic energy there is how much potential energy there is going to, or however much potential energy there is how much kinetic energy there is going to be. So I'm going to show you all some more examples. So here we have a car stopped at a stoplight. It has the potential to move, but it's not. whenever you take your foot off the brake and give it energy in the form of gas, it moves to kinetic energy, right? Stopped, has the potential to move. Kinetic energy, it's actually moving. Here we have a little boy who is about to throw a ball. It has the potential to move. When he releases the ball, the energy transfers to kinetic energy, okay? Potential, kinetic. Not moving, but can move. Energy in motion, it is moving. And finally, we have a car sitting at the bottom of the hill. As it goes up the hill and it sits here, it has that lag time, right? You all have ridden roller coasters or ridden rides. When it goes up the hill, it has a lag where it does not move. It's just sitting there. It has potential energy. As it goes down the hill, that potential energy transfers to kinetic energy, okay? So, like I said, this is a review. I'm going to post a picture of your anchor chart for you to copy. You're going to copy it on a piece of paper, take a picture of it, and upload that to Google Classroom as your first assignment for NTI, okay? If you all have any questions, feel free to contact me. I will also link a couple of supplementary videos for you to watch. Probably one of the Newton's Laws videos that we have watched, just something for you to review, okay?